All right, so this is number 7 on the final exam prep for units 1 through 5, that second packet. So we have which of the following must be true. All we're given is that the limit as I approach 3 of f of x equals 7. So let's draw a counterexample to some, if not all of these. So if I were to make a line, I actually have a line tool, so let's make a nice graph. So there's our graph. Let's say our function is really simple. It's a line, and then all of a sudden there's a hole in it, and then it continues on. So there's a hole in it right here. Come on now. Let's draw a circle. Doesn't like me. Okay, so there's a circle right there. There's a hole in the graph, and we'll say that at this point right here, that's going to be x equals 3. So as I get closer and closer to this point, I should get 7. Well, it's not drawn a scale, but as I get closer and closer to this x coordinate, I get closer and closer to the y coordinate 7. That is true. This is true for the limit as x approaches 3 of this function. It does approach 7. All right, is it continuous at x equals 3? Well, it's clearly discontinuous. I mean, there's a break in the graph here, so it's not continuous. Is it differentiable? Well, if it's not continuous, it can't be differentiable because one of the definitions of differentiability is it needs to be continuous. And that makes sense also. You can't find the derivative at this point. You can't find the line horizontal to something that doesn't exist. And does f of 3 equal 7? Well, no, it doesn't exist anything. F of 3 is DNE, so it doesn't exist for that one either. So the answer is none. And you could have had another counterexample. You could have had a point up there. You could have had a bunch of different types of graphs, but you can make a graph where all of these are not valid, where this holds true.